So this is the handle that we're doing. We're going to make a replacement version of this. These are not available anymore, and we're missing one on the other side, and I want it to look stock, basically. So anyway, let's go take a look at the other side, because there's some differences on the other side that are worth talking about. So this is the motor side, and I'm really glad that I that I pulled this handle out. So there's the handle and the stem, and then there's the latching element, which is like a helix. Well, here's the bar that it catches on. Now on this side, it actually turns out that this stem is considerably longer, and that's what I got this rod in here for. I just happen to have a piece of 7/16 diameter rod, and I'm glad I checked and not just copied this and then tried to put it together, right? So it turns out that the stem on this side needs to be, about almost an inch longer than the opposite side. So anyway, I got all my measurements. I'm pretty happy, and so we can actually kind of start on the handle part itself, and then this is an interesting little project in itself. This little helix that catches the edge of this and then pulls this door closed snugly, and you can see where it's been rubbing on the other side. So we're gonna make a facsimile of this, something that's pretty close to that, and but let's get busy. All right, so here's the job. So this is one that my friend Metal Master Mike 3D printed for me. So I measured the whole thing up and then modeled it, and then he 3D printed one just as kind of a check for fun anyway. So that's that. Now here's the original. So the first part we're going to do is this stem and the spherical part here, and then the tapered side handles will be added on later. And the idea here is they got a thread here and a thread here, so we'll screw these together. I'll use a little stud or a set screw to hold it together, and then what I want to do is I want to weld this, I think. That way I can get a nice little blend there. We'll see what it looks like. It may not need the welding, and it may be secure enough and look nicely. But this has got a nice little radius in here, and I was thinking that I wanted to try to duplicate that. But that's kind of a wait and see. We can see what's going on. So let's start with this the blank for this this spherical portion here, and there's a couple ways that we can do this thing. To make this sphere here, this spherical part. So one is, actually I'm going to change drawings here, and then, no, I'm not going to change drawings here. So there's a couple ways we can do this. So one is with just a radius tool here, right? And, we would call this a form tool, and we would just form that radius. Now, this is a pretty big tool bit here, and it's not actually even giving us the full radius, right? So we'd have to do this in a couple of steps, right? Like, so there's half, and then we'd have to come around the corner to do the rest of it, right? So there's some matchup things, and when you're cutting steel, and we're going to make this out of steel, by the way. When you're cutting steel with a big broad form tool like that, it's subject to chatter and whatnot. So the other way is with spherical generation, and that's where we use a boring head or a hollow cutting tool, and we hold this at the appropriate angle, okay? And let's see, do I have something, an analog here? So the spindle's coming down like this, and then we're rotating this spherical, or our blank, this way, as we're rotating with a cutting tool this way, a hollow cutting tool. So this is true spherical generation, right, as opposed to forming or sweeping with a single point tool. So it's a little different than those methods, and it produces actually a true sphere. This is how they grind spherical lenses, and this is how they make precision balls and things like that. So I think that's the way we're going to do it, because we can control the finish of that sphere a lot better. So, and then here's our blank that we have to create to start with. And I actually, this has this shank coming on it here too. That's not shown here. So we're going to make this blank first, and then go over to the mill and set the mill up to do the spherical part. This will be pretty fun. So this diameter will stay the same. So we're just doing the shank part. So we're gonna, instead of turning that 7/16 stem on this, I'm gonna insert a rod, just because of work holding problems, reaching over the sphere. You'll see in a little bit. Okay, I think that's the bottom. So let's talk about spherical generation a little bit, just so you guys get the idea. So I had this is a nice example here of a sphere with a stem. That's what we're doing here. Just so you guys know, it's difficult to make full spheres because of the work holding. You always need some little stem to hold on to do the work, right? But the way this works is the spheres are unique in that we can use a circular cutting tool, and any circle, as long as it's smaller than the diameter of the sphere, will actually sit on that sphere and touch all the way around, as you see here, right? So that's one particular diameter there, right? And then here's another diameter, and you see that we're covering more of the sphere. And in fact, if you want to make a hemisphere, okay, a full sphere, the circle diameter to cut that full sphere is actually the diameter, okay? And then, so if you want to do a hemisphere, that would be a quarter, the hypotenuse of the from the equator to the pole, right? Does that make sense? Yeah. So there's also some angularity. So if we have to present at an angle, and the cutting tool edge has to pass through the center of rotation, right? And this produces an actual true spherical surface, which is the intersection of two rotating axes. So this is our cutting tool rotating, and then this is our work holding rotating, right? And we do that with this tool over here, and I'll show you that in a sec. So, so that's kind of, that's the theory of it. So we can use, now the tool has to cut on the periphery, okay, of the tool, right? A solid cutter doesn't work, right? We have to have a hollow cutter like this, or something like this, right? And you see that sits on there. So that would actually work there. Although we don't have any control over that diameter. That would only do a sphere or a portion of a sphere of a particular diameter, right? So we have to be able to control that diameter. So how do we do that, right? There's a couple ways we can do that. And one is we can use a cutting tool like this, okay, which is a boring head that we can adjust. And here I have it set so that the cutting edge is pointing inward, so that when this sweeps, right, it cuts the spherical shape. And then we can adjust the diameter very precisely here to produce a sphere of the diameter that we want, okay? So let me get the drawing. I forgot to bring the drawing over here. And then I can show you a little bit better. We'll kind of set it up, and it's a little easier to see once it's set up. Okay, so here we have our rotating work holding axis, and then here we have our spindle, our rotating spindle axis. And so this is, I took a piece of conduit and I glued a 1-inch ball to it, just to help our conversation here a little bit. So let's put this in here, and you'll start to get the idea. So there's our holding stem that I was talking about, right? And then this rotates under the spindle. So this is a 90-degree angle here, approximately, right? So if we were using a cutting tool here, like so, say that it was this diameter, we would produce a portion of a sphere that has the stem on it, and then it would also have a projection here because we're not reaching the diameter. Hope that makes sense. So if we were doing a complete sphere, this would have to reach, it would have to be the correct diameter, 1 inch inside in this case, and it would have to reach all the way to the center of rotation there, right? Now, clearly that would cut away our stem, right? Our holding stem, so that doesn't actually work. So what we have to do is we have to present this at an angle, okay? Now, let's see here. Hopefully it's going to blow out the camera here. Okay, you can kind of see it. So here's the one that we're doing here, okay? So that's I don't have it labeled, but that's a 1-inch diameter there, and there's our holding stem. And so our cutting diameter is 908 inches in diameter, and that represents to the intersection of the stem to the pole, okay? And that's our what I call the swept diameter, or the cutting diameter, right? So we need a hollow cutter like this with a cutting diameter of 908, okay? So that's what we need. All right, we're gonna raise this up to our angle here, which is 24 3/4 of a degree. About there, it looks pretty good. Okay, I'm just gonna cinch it down. So there's our angle that we're gonna come down, okay? And obviously we need a cutter that's a little bit bigger in diameter than that. Okay, a hollow cutter, and you can kind of see what's going to happen. So this is going to be rotating, not this particular one, and we're going to rotate underneath that. So that cuts away all the material that's projecting up inside the cutter, the hollow cutter. Okay, so now what we're going to use is, I made this one up that cuts at that specific diameter. Okay, and this cuts at this 908 diameter that we need. So it's going to sweep around here like that. It's a single point tool, and we're going to rotate underneath that, and we're going to cut a sphere. So here's our hollow cutter, and the next thing we have to do is we have to align it with the blank. Here's our blank, right? But what wants to happen here is we want to be on center in the Y direction, and we want to be on the desired spherical center too, right? Okay, so let's just visualize that a little bit. We'll put this little pointer up in there. Okay, and you can kind of get the idea. So actually we're pretty close on the Y, and actually we're in not bad shape on the X. It looks like it needs to go this way just a little bit. I'm just eyeballing it to get it close. So let's pull that out, and then we'll come down very carefully here. I'm in neutral, and what I want you to see. Let's see. I don't want to nick my tool here. Yeah, it looks like I need to go back a little bit. Oh yeah, definitely. Okay. Yeah, sometimes it's I find it difficult to judge the center of a sphere for some reason, you know. Anyway, it's just an optical thing. But anyway, that's the idea, right? So this thing's swimming around like this, and then we're actually cutting this, and you can see that we'll be cutting that material away, right? And when the blank's here, there's material that's projecting, well, actually at the equator there. That's the last bit of material that goes away, right? But so it's all this side material that's being cut away as we rotate underneath it. And you know, it doesn't really matter which direction you rotate this axis here, our rotary axis, because the cutter still sees it in the right direction. So anyway, that's the general idea there. I hope you can visualize that. And like I said, let me get this out of the way for a sec. So this is our setup here, and this is the diameter that we're sweeping right there, which is that intersection from the stem shoulder to the pole. And that's the center of rotation, that axis there. So does that make sense? Hope it makes sense. And so I think we're kind of ready here, and I'll show you some ways that you can pick up these corners and these edges accurately. Obviously we can edge find to find the center. This corner, we have a little trick for picking up this corner if we want to do that. Or I've left a little pip there, and we can use the edge of the cutter on that pip to line up too, so to help us line up. And then as you start cutting it, then you'll see what's happening here at the pole and make any fine adjustments from there. Because there is run out to this whole system, right? In particular with this axis here, right? So there is a true axis of rotation, right? And if you put the an indicator on here, there might be some run out, but there's some system center line that it's rotating on. I hope that makes sense. So let's go ahead and pick up the center of this thing in a couple of directions. So we're just gonna do a simple edge find on the side here. And a little bit. So that's one direction. All right. And then, so I don't know if I mentioned it before, but so we can pick up this corner. We can pick up this corner so that we can actually get onto the center line of the sphere, right? And how we do that, hopefully you can see that. So I got this number 245 here, and that's off of this corner, right? So we need to pick up that corner accurately, right? That would be the task here. And you can use something like this here for that job. And what this is a known diameter that sits on that intersection, which is kind of nifty, right? And then, actually, I'm not going to do it. I'm just going to eyeball the corner here because it's not a fussy thing here. But you can edge find this. Actually, let's just go ahead and do it. Why not, right? Why not? What the heck? What do we got? Okay, that's why. Because you drop stuff. All right, now I got to find it. Okay, didn't go far. Okay, so what we're going to do is I'm just going to hold this. All right. This ought to be interesting. Okay, now let's get this out of here. Zero that. Come in 100, which is half of the edge finder. Let me turn this off here. And then, actually, you know what? I'm going to put this back in place so you can see it. And then we're going to come in 1/4 of an inch to 50. Right there, okay, and then theoretically we're dead nuts over that corner. Now what I want to do, since, well, actually it doesn't matter, and we're just going to start right there. So we got our numbers. Let's see, let me make sure I'm, yeah. All right. Well, let's zero all that so we know where zero is. Okay, let's get this out. All right. So we're ready to start cutting our sphere here. So let me get set up and get a good shot going for you guys, and then we'll cut that. All right. So we're going to do our little bozo check. So we've moved over the 245, and then this is our cutting edge here, and that should fall visually on the center line. I'm bringing it down, and it looks pretty good to me. Okay. So, yeah, so I'm pretty happy. So let's get the... Probably something like that. Probably okay. Let's get some liquid love on there. And then So this is about where we're going to start cutting here, right in that regime. All right, I think we're ready. All right, let's go down until it starts tapping, like that. I don't know how well you can tell, but you can already see that there's a radius on that corner. Alright, let's take a little more of a cut. And there it's meeting up with the back edge cut. Go. That tool is actually working good. I'm not happy with that finish. Yeah. So we're not cutting on the back side just yet. We'll be here in a sec. Started cutting on the back side now. Chips are hot. You can see the backside cut now, right? And you see that equatorial band there, right? We're going to cut until that band blends in. Pip there, so we're going to come down a few thousandths. I'll take some light cuts now. So the difference is in that band. You see there's a narrow spot and a wide spot. That's run out in this chuck probably, and a run out between the part and the spindle axis. So there it's pretty much faded out, and there we got a little bit left. So I think the answer to that is I'm going to go a little bit more. I want that gone. Okay, that looks like we're crossing it there. Let's do this so I can get some. This probably is a finish cut. Yeah, that looks pretty good. Close enough for me anyway. Yeah, that looks nice. I'm going to call the ball here. Yeah. Oh yeah, that's pretty good. Looks like a sphere to me. Okay, so we're set up to do our cross hole now, and you know, picking up the center of a sphere is mildly interesting. It's kind of hard to use an edge finder on it because it's spherical, right? And you don't know if you really need to be on center to determine where the center is. So the best is to indicate it. But what I want to do is I want to get kind of close first. So I know that the distance approximately, and this is just to kind of get me an indicator range here, from that little intersection right there, from the top to that intersection is 825 according to my my layout. So we're going to move over 412 and a half. Yeah, right about there. Okay, and so theoretically that should be pretty close to the center. So, but we're going to determine that. Oh, and I forgot to mention, you know, side to side is pretty easy here because I have a cylindrical shank on this, but you'd have the same problem doing that. Okay, so let's do this. Let's get down. I want to make sure that I'm on the sphere. Okay, I got the indicator going. Oop, and it's okay. I don't know, it's a mile off. Okay, so we need to go that way quite a bit. So let's just back up and we'll do it the dumbbell way. All right. And of course, I don't want to hit the camera with my head because that happens regularly. I'm touching there. And I'm touching there. Okay, I'm on a little bit. All right, that's pretty good. All right, now, so I'm roughly centered now. Move that in a little bit so I can get a little more range out of the indicator. All right, close enough. Okay. Off that way a little bit. Okay, so pretty close. So, like I said before, the the indicator is sweeping a circle, right? And a circle, ouch, a circle will lay precisely on a sphere. Boy, this is a pain with the with the camera where it is right now, unfortunately for me. All right, it's looking pretty good. Yeah, I'm gonna call that good. All right. One more. Yeah. Okay, that's good. Okay, so we are on the center of the sphere now, despite my best efforts. And so we are going to put a flat on that, and then we're going to drill through and tap that. And we're going to put 2 counter bores for our handles to seat into. So I used a nice stiff spotting drill. Oh, very carefully here. I don't want to go until I just get a little step there. Like that. I want to go a little more. Maybe I ought to look at the drawing, huh? According, I didn't have. We'll go down to the same number. All right, so I got a piece of stock in here. This is going to be our little side arms for the knob here. So we're going to turn a taper on that and drill it and tap a hole in the end so that we can attach it to the sphere that we just made. So anyway, this is just cold rolled steel here. So let's get to it. Now, turning a little shoulder here. This step interfaces with, I want to make sure that my diameter's tracking there. 47, yeah, okay, pretty good. This interfaces with that little counterboard that we put in the sphere. Do a little bit of taper turning. It's just a reference point, so it's not anything that's this is 6 degrees per side. Finish pass. Okay. Why does it always do that? Okay. All right, so now we got to put a little relief in here. We're going to use a radius tool to radius that back edge. To radius this back edge while we still got a hold of it here, right? And so I need to cut a relief in there somewhere in that regime. to clear the tool. Not too deep, but not too shallow either. That looks pretty good. Let's try that. Get this out of here. So there's the radius tool. Now, you know what? I think I'm gonna run this slow, just 'cause. Okay, get lined up here on the world. That looks pretty good. I get 2 radiuses for the price of 1 with this tool. This is a tool that I ground many years ago that I could do right and left at the same with one tool. Oop, come on, clear them chips out of there. Okay, that looks pretty good. There we go. Well, let's this out of here, and then what I want to do is I got a little piece of all thread here. We're going to run that down in there and bottom it out. I want to snug it down a little bit like that. Then I'm going to whack that off and leave a little bit sticking out, and that's going to thread into the sphere. So let me go do that, and we'll try it. I'm pretty happy with that. That thing looks pretty good. You know, it has this little radius in this corner here, and at first I was thinking I was going to weld that, right, and then blend that radius in, but you know, I don't think I'm going to do it. It's I'm going to Loctite that, screw them together nice and tight, and this will get painted, so there'll be some paint radiusing there or whatever, right? And there's our 3D printed one. I don't think it needs that. Now I got to figure out how I can finish these ends, because you know, it's kind of hard to grab onto these, right? So I'll probably take it back apart and screw that into something in the lathe so I can turn it and then hand finish that those ends and blend that radius nice and polish these up a little bit. So, but yeah, I'm pretty stoked. It came out pretty good, and I still got to shorten this a little bit. That's easy, and then pin a shaft into that, and then I'm done. What do you think? I'm going to do a little polishing here. And this little sucker. Alright. There's our victim. Our victim. So I did a little hand filing to knock the pip off, and so I don't have to do so much over here. Okay. And what I'm using is, this is just Scotch-Brite here. And this particular little grinder has variable speed, so I can slow it down to kind of get the effects I want. So let's do that. Okay, Mr. Wizard, watch out. I must have got on the top side of it or something. Huh. Why is it doing that? Why does it keep doing that? Shouldn't do that. Well, let me get, you know what, I need to tighten that up a little bit more. Hold on. I don't know if you guys ever saw these. I made these, I don't know, a while ago. But they're channel locks with copper jaws so they don't chowder up surfaces like that. Alright, that should help. So we're putting a roll pin in here, and I'm going to drill at 128. So roll pins, especially small ones, you got to be a little bit careful with them because they definitely are larger than the nominal size. So I tend to drill them. I measure them and I just drill them slightly over the nominal size, but less than the measured size of the pin. So this one measured 134 and I'm drilling 128. It's just makes it a little easier to put them in, and so that you don't mushroom them or bend them or do anything nasty there. And you always want to drill through. That way, if you ever have to take it out, you got a chance of getting it out. Okay. And then, what I do is I go, since I'm already there, right? So sometimes you can get them started nicely. I'll finish it off when I pull it out of there, so I can see the other side. Well, let's just do it. Oh, not bad. Okay. All right. Almost done. Okay. All right. Cool. pretty good. All right, friends. That concludes the handle. I decided I'm not going to weld it. And there's the model. Well, that's the model, although let's get rid of that. That's plastic. It's not real metal. I'm going to leave this long because this next part that we're doing for this is this latch piece. So this presents some unique challenges in itself here. So this goes on the shaft and cams the door closed. It pulls the door closed. And so we're going to make one of these because we're missing this. And I got an idea how to do that. And you see that's got a nice helix to it, right? That ought to be fun. Huh? That'll be fun. Okay. Anyway, thanks for watching. Hope you like that. And then stay tuned for this next bit here, the cam. So we did the handle, now we're going to do the cam.